interior angle bigger than either two remote interior angles, and then biggest side across from biggest angle. There's a third one today you're going to figure out in your groups here. All right, this is going to take a while with our group activity. And just to give you a little preview here, when you have a triangle, believe it or not, you cannot have any three side lengths you want. Like if one side's 3, the other side's 5, and the third side's 20, that won't form a triangle. All right, the 3 sides have to fit under a certain rule. And you and your group today are going to figure out that rule. You cannot have any 3 sides. So we're going to get back to that triangle after you guys figure out the rule and say, well, why won't that form a triangle? Right? Why didn't it fit into the rule you and your group are going to come up with? So what I'm going to give you now, I know it says straws up there. All right, I'm going to try to make it somewhat interesting. I'm going to give you and your group some licorice. Let's act like we've seen food before. All right, and not act like savages. Here's what you're going to do when I give you licorice. I had a smaller class last period, so we may have to share rulers. You and your group are going to cut, once I give you your licorice strips, you're going to cut a 2-inch piece, a 3, a 4, a 5, and a 6-inch piece. All right, and that is for the entire group. All right, not for each individual. The entire group is going to have a 2, 3, 4, 5, and 6-inch piece. How you want to cut them, that's up to you guys. All right, but I'm going to give you the strips right now. These are the type that you can peel off as well, if that helps you out, if you're running out of room. But I want a 2 through 6-inch piece. That's all I want. Okay, and then I'll tell you your next steps. So measure them out. Two through 6-inch piece, and you can peel these even more if you need to. Okay.
These are the ones that come out.
Okay, get to work. 2 to 6-inch piece.
Do we like take it?
I don't care how you cut them either. That's your deal. But I need a 2 through 6-inch piece. Make sure you know which one's which, because that's important in the next step.
Hey, anybody got scissors? Yeah, we got
Wait, no. Just take it apart.
That's what I was doing.
You can.
You literally just said you could.
Oh, wait, six.
Wait, which one are you gonna do?
The 6-inch.
You can get the 3-inch or the 2-inch out of the
Here's the 6. I found it.
Okay, I'll do the 4 and the 5.
That's 6.
Here you go.
Okay, what else do we need? And then this one.
What are you doing? Somebody give me
3 and 4.
I'll do the 4 and the 5.
Wait, literally.
I'll do the 2.
Oh yeah, there's a strip
What
out.
else do we need? Great.
The great British baking house.
And we do 1.
No,
I like the rest. I don't know where to put it.
We'll have
That's 6.
6, we'll do 2.
I like the small.
Here's 5.
Now we need a 4.
It's what? Oh, the 5 actually split itself into 4. So.
Yeah, exactly. 6. Wait, I'm having 6.
Yeah, 2.
Okay, hold on. I gotta fix it.
They're gonna stick to it.
Because it's not gonna be all sure. And I want to cut it.
No, let's use this.
Okay, start finishing up, please. Start finishing up.
What's this?
We've already got our hands all over it.
We got them all our pieces set now, so I can go on to the second step. All right, now what you and your group are going to do is you're going to select 3 pieces. All right, write the lengths down in the chart, and when you write them down in the chart, just so you can see the rule a little bit easier, write them down from smallest to longest, please. All right, so if you do 4, 3, 2, make sure it's 2, 3, 4. And what I want you to do is, does it form a triangle or not? And here are the rules here. If you have extra, like an exterior angle, that's a no. All right. If you come up short, that's also a no. All right. All three vertices must be touching without any extra or with anything shorter. All right. It's got to. So what I want is, again, pick 3 lengths, jot them down from shortest to longest. If it's a yes, write it yes. If it's a no, write no. Here's what I would like: 3 sets that do, 2 sets that do not. That's your goal in your group. Find 3 sets of lengths that do form a triangle, 2 sets that do not. If there's controversy and arguments, some say yes, some say no, call me over and I'll settle it. All right, go ahead. You get another 2 minutes here. Please list them shortest to longest in the chart, though. Does it form a triangle or not?
Wait, which ones are they?
I think I know what the theory is.
It's a little
What numbers are these?
Yes.
Oh, wait.
Wait, what is it? 4, 5, 6.
I know that. Yes.
No, if you have to pull them together.
Okay, just give us a second. What is this? 3? Wait, that's 5. Sorry.
Not all of them are completely that. Because of that.
Yeah, but I don't know. Why don't we just ask him?
I think that's so.
Yes.
I'm not gonna say
Oh my gosh, wow.
Okay, so now we're doing
If we're wrong, it's not like the end of the world.
No, go ahead. What's your lengths? Tell me your lengths.
2, 3, and 4.
That should be fine.
This is Now what are we on? 2, 3, 5.
2, 3, 5?
No, we gotta give a last one.
2, 3, 5.
Let's do a.
6
Let's do a.
No.
Again, make it easier on you. Make the next step easier. Rank the sides from shortest to longest in your chart. That'll make the 3rd step easier.
No.
At least.
It wasn't done.
No, they're together like that.
Well, the guy like. Yeah.
Alright.
6, 5, 4.
2, 5. I guess it's yes.
They are.
What's this? That's just the way.
I think it's supposed to be.
3 sets that form a triangle, 2 sets that do not.
Let's try
What
3,
about
4, 5.
3, 2, 6?
It's being honest.
That's not the word.
Are you feeling
That's 32. Look at that one.
4, 6.
It's 3, 4, 5.
What's that?
3, 4, 5.
Let's have a brain contest.
That's it.
One more, the
One, 6, and
Yeah, that might work. I think I know what the theory is. That.
All right, start finishing up, please. Start finishing up. I'm going to call on each group to let me know what one was a yes or a no.
Have to be the same. Technically, yeah, let's do all 3 times.
Okay, you're telling.
Don't have to be greater or greater.
I got
Yeah, there's extra. What was it?
Okay, let's talk here. Here we go. Let's talk. I'm going to go around to each group and ask each group for a yes or a no here. So this first group up front, what do you got for a yes for me?
2, 3, 4.
2, 3, 4 should have worked. Yep. That would form a triangle. Group in the back, give me another yes, please.
4, 5, 6.
Yes, that would have worked. You guys up front, another one that worked.
3, 5, 6.
3, 5, 6. Yep, that was a good one. All right, let's go to the no's now. You guys have a no that didn't work?
4, 2, 6.
2, 4, 6. Yep, that should not form a triangle. 2, 4, 6, not a triangle. And how about one more that didn't work? Group over here.
2, 3, 6.
2, 3, 6. Correct. Should not have worked. And I'll add my own in here. That shouldn't have worked. 2, 3, 5. Should not have worked. All right. Now, I don't memorize these lengths, but as every group gave me their side lengths, I plugged it into a certain rule to say yes or no. I'm going to give you guys a minute and a half. What rule am I using to say these three sides will, these three sides will not form a triangle? All right. So what rule am I using that says only if the sides fit into this rule will it form a triangle or not? Talk it over about a minute and a half. See if you guys can find a pattern or a rule that I plug all these three sides into.
Yeah, like, they're all.
And I tried to have you guys list them from shortest to longest for a reason to try to help you out a little bit to see the rule.
The two shortest sides have to add it to something greater than the longest. Because think about it, 2 and 3, 5 is greater than 4. 2 and 3, 5 is equal to 5, so it doesn't work. 4 and 5, 9, that's greater than 6. 3 and 4, 7, greater than 5. 2 and 3, 5, less than 6. 2 and 4, 6, greater than 4, 5 doesn't make any sense though. The sum of the two smallest angles must be greater than the length of the other.
They add up to 180. That's how we did it. It was not like that.
I hate Twizzlers, but every time I have a Twizzler,
I don't think that's what it actually told like at that time.
Oh, there's like Twizzler stuff.
Wait, so in theory,
So it didn't really
2,
work
4,
out.
5 should have worked then.
All right, let's talk. Somebody want to just give me the rule in their own words, and then we'll write something official down in that text box below here. Simon, what do you got?
The first two sides must add up to more than the last side.
So what do you mean the first two sides?
Or the first two like smallest ones.
Okay, and it's any two sides too. All right. Any two sides of a triangle have to add up to be bigger than the third. And the quick way to check is what Simon just told us is if you take the two shorter sides, add them up. If it's bigger than the third, then all of them will be bigger. All right. So for instance, 2 plus 3, bigger than 4. But if you look down at all the no's, 2 plus 4, not bigger than 6. It's got to be greater than. It doesn't count if it's equal to. Going back to my original example. Everyone see why 3, 5, 20 is not going to work anymore. 3 plus 5, no way that's bigger than 20. All right, so let's write something official down called the triangle inequality theorem. And it says in a triangle, sum of two sides. And again, I use the word sum because what am I doing here? Addition, right? Adding the sides. Sum of two sides must be, now take a look at what I'm going to write here, greater than. Notice I'm not writing greater than or equal to. Greater than the third side. And the quick way to do it is pick the two smaller, add them up. Is it bigger than the third? If it is, it works for any combination. Works for any combination. All right, let's test our ability here. I'm going to start calling on some of you. I have 5 different triangles up here in the next problem on the next page. 5 different triangles. With these sides, will it form a triangle or not? If you're going to say no, explain to me why. If you're going to say yes, I don't need an explanation. So if I have a triangle that's got side lengths 1, 2, and 3, will that form a triangle based on the activity we just did and what we just wrote down? If I have 1, 2, 3, is that good enough to form a triangle or not? Let's start here. Tess, what do you think?
No,
Why not?
because 1 and 2 equal to 3.
There you go. Yep. 2 smaller sides do not add up to be bigger than the third. How about 2, 4, 5? Good to make a triangle. 10, Henry, is that good?
Yes.
Yep. It all works. Pick any 2 sides, always bigger than the third. How about 5, 5, 6? 5, 5, 6. Zoli, up to you.
Yeah.
Yes. And another question, everyone else, what type of triangle is that? 5, 5, 6. Isosceles, yep. 2 sides congruent. Good job. 8, 13, 21. I'll give you guys a second there. 8, 13, 21. Will that form a triangle? What do we think? Ones, Micaiah? Nope, why not? Yep, 8 and 13 equal 21. Got to be bigger. And then finally, what about 10, 20, 25? Going all around here. Dylan.
Yeah.
Yep. All right, good work, everyone. So that's the first thing I need is given 3 sides, can you tell me if it's a triangle or not? Second thing I need you to do with this fact. If I give you 2 sides, what could be the third? Because we just went, it can't be anything. So this first problem here, hey, one side is 4 inches, the other side is 7 inches. Give me possible values of the third side. Now look, right, you can't tell me 50 here. Right? 50 is not going to work. Doesn't fall into adding 2 bigger than the third. But there are more. Everyone agree there's going to be more than one answer. All right? And I don't want a list of numbers either. All right, of all the possible third sides. Here's how we're going to write it. And this is something I hope you guys did last year. Did you guys ever do the ones with 2 inequalities? You remember what inequality? Remember the signs less than, greater than? And you probably did problems where you had 2 of them? Like that? Okay, that's what we're going to write our answer in. We're going to say x is our third side. That represents the third side. And you tell me what the third side has to be between. Does it have to be between 1 and 50? 2 and 20. We're going to figure that out right now. All right, let's actually, for this problem only, let's list off what are the possible lengths that third side could be. Because it can't be anything. You got one?
Anything greater than 4 or equal to 4.
All right, so can it be 4? Is it all right? The third side's 4. All right, let me go lower. 3. Could the third side be 3? No, why not? 3 plus 4 is 7. All right. Well, how much bigger than 4? Because there's only certain, right? I can't go. Stellan said, hey, anything bigger than 4, which is true, but there's going to be a cutoff point sooner or later. Ready? Could it be 5? Is 5 okay? 5 plus 4, yep. 6 okay. Would 6 still work? 4 plus 6, right? 7 work. Don't go by my tone either. Just apply the rule. So would 7 work? 4 plus 7, bigger than 7, yep. All right, 8. It's going to end sooner or later, but would 8 work? Take your 2 smaller sides right now, which would be 4 and 7. That's that bigger than 8. Yep. Would 9 work? Yep. 10 work? 11. Why wouldn't 11 work? 4 plus 7 is 11. It would need to be greater than 11. So it looks, whoa, don't write anything down though. So it looks like anything between 4 and 10. Don't write anything down though. Don't write anything down. I'm not done. Could it have been 4? Could I have had a side length of 4? That would have worked. Could I have had a side length of 10? Yes, but my inequality is not saying that though. Anybody remember what I need on them to say it includes 4 and it also includes 10? Simon. Yep. Don't write anything down yet. Everyone remember the or equal to? Okay. You're missing stuff though. You're missing something. Let's see if we really understand this. Ready? What if I wrote 10.1? What if the side was 10.1? Would it still work? Is 10.1 still good? 4 plus 7 bigger than 10.1? But it's not here. You stopped at 10. Would 10.9 work? But you stopped at 10. Would 3.9 work? Let me put 3.9 here. Would it still work if that side was 3.9? What's 4 plus 3.9? 7.9 bigger than 7? But is that in our inequality? Nope. How about 3.1? That would still work, but it's not in our inequality. So you're going to have to go back in your group right now for about a minute. This is not going to cut it. 4 and 10 is not going to cut it because I'm missing all these decimals now. So you figure out in your group, what can I write now? So it includes everything now. Includes everything. All right, so I'll go back to my original here. I can't use 4 and 10. You're not including everything we just saw. You're missing some decimals. So what can I put on there? And don't put 3.1 because now you're missing 3.09, 3.08. Okay, I need something here. Think we got anything that fits every possibility? We got anything that fits every possibility, including the decimal answers up here? Anybody think they got numbers attached there? Bailey, what do you and your group have?
X has to be greater than 3 and less than 11.
How about 3 and 11? Should I put the little lines underneath or no? Okay. Does that now include 3.1? Does it include 10.1, 10.9? Does it include that? Yep. So this is what we ended up with. That third side has to be somewhere between 3 and 11. That took a while. Okay, that took a while. What if I gave you numbers that are even further apart? It's going to take even longer. It's going to get frustrating and annoying, and I get it. Is there a way I can get to this quicker then? Go back to the very beginning of the problem when you only knew the two sides were 4 and 7. Wait, the two sides were 4 and 7, and we said it had to be between 3 and 11. Can we get to these numbers a little quicker than listing out every single possibility and fitting it into the inequality? Because that took us like 5-6 minutes, and I don't have time for that. Is there any way in your groups you guys can figure out, oh, if he gives me these two sides, so let's go on to the next problem. If he gives me now 9 centimeters and 17 centimeters, can I do this inequality a little bit quicker than trying to list out all the side lengths? Go ahead in your group. It should only be about 30 seconds if you figure out what you can do with the two sides. What can I do with the two sides so I don't have to list everything out? Remember, I went from 4 and 7 to 3 and 11. I had 4 and 7 and got to 3 and 11. Because if we had to list out the sides here, it would take us a while. Okay, let's get back. X has to be greater than, what do you do in the 17 and 9 to figure out what that third side has to be greater than? What can I do with 17 and 9, Jonathan?
Adding and subtracting.
I can subtract them to figure out what it's going to be greater than, and add them to figure out what it's going to be less than. Yep, that's how you can find the possible third sides. So if I do that for the last problem, whew, 11 and 20, that's going to be a lot of choices. A lot of choices. I don't think you want to list them out. So that means it's got that third side has to be between what two side lengths when you're ready? Jonathan, what two side lengths does it have to be between? 9 and 31. That's why you don't want to list them out, because that's a long list between 9 and 31. Any questions?